Okay, oops, there we go. This is Mrs. Ward reading chemistry book, chapter 10, section 3. This is part 2. Okay, so we are on page 294, and there are some example problems for you to look through and solve, and some practices. I recommend you do this. I'm guessing those will be on the test or things similar to that, so those are good practice for you. There's also a mini lab. I know you're doing labs in class. Okay. So, reactions that form water. Okay, so the first reaction we looked at were reactions that formed a precipitate, right? A solid. Now we're going to look at reactions that form water. Another type of double replacement reaction that occurs in an aqueous solution produces water molecules. The water molecules produced in the reaction increase the number of solvent particles, right? Water is the solvent in the aqueous solution, and so there becomes more water in the solvent. Unlike reactions in which a precipitate forms, no evidence of a chemical reaction is observable. You can't see it because water is colorless and odorless and already makes up most of the solution, so you're not going to notice it. For example, when you mix hydrobromic acid with sodium hydroxide solution, a double replacement reaction occurs and water is formed. How do we know? We'll look at the chemistry in the chemical equation. Okay, this is hydrobromic acid in aqueous solution and sodium hydroxide in solution, and they react to produce water and sodium bromide in an aqueous solution. The water is a liquid, so you're not going to see it. In this case, reactants and the products, sodium bromide, exist as ions in an aqueous solution. So the complete ionic equation, it's going to include those spectator ions because it's a complete ionic equation. The complete ionic equation for this reaction shows these ions. Okay, what are they? Hydrogen ion, bromine ion, sodium ion, hydroxide ion. They react to produce water and sodium and bromine. Now, which ones are we going to cross off? Whatever did not react, we're going to take those out of the net ionic equation, okay? Those are called spectator ions. They don't react, they just sit there and watch everybody else do the work, right? Look carefully at the complete ionic equation. The reacting solute ions are the hydrogen and hydroxide ions. Solute are the things that are dissolved in the solution, okay? The reacting solute ions are hydrogen and hydroxide ions because the sodium and the bromine ions are both spectator ions. Sodium doesn't do anything. Look, it's there and it's there. Bromine doesn't do anything. It's there and it's there. We can cross them off. So if you cross out the spectator ions, you are left with the ions that take part in the reaction. Hydrogen ion and hydroxide ion react to produce water. This equation is the net ionic equation for the reaction. Okay, here's some more problems for you to work through. I recommend that you do them in your own time. Reactions that form gases. A third type of double replacement reaction that occurs in aqueous solutions results in the formation of a gas. Okay, so we've seen reactions that form solid precipitates, we've seen reactions that form water, and now we're looking at reactions that form gases. Remember that all of these are ionic compounds or that are forming these double replacement reactions. Some gases commonly produced in these reactions are carbon dioxide, hydrogen cyanide, and hydrogen sulfide. I would be paying attention to these. You're looking for the opportunity to see these gases in ionic reactions, okay? So pay attention. Carbon dioxide, hydrogen cyanide, and hydrogen sulfide. These are common. A gas-producing reaction occurs when you mix hydroiodic acid, HI, with an aqueous solution of lithium sulfide. Hydroionic acid with lithium sulfide. Bubbles, a gas. Bubbles of hydrogen sulfide gas form in the container during the reaction. Lithium iodide is also produced in this reaction and remains dissolved in the solution. So, hydroiodic acid in an aqueous solution and lithium sulfide in an aqueous solution react to produce hydrogen sulfide gas, which we would see as bubbles, and lithium iodide in an aqueous solution. Okay, this is not an ionic equation though, right? This is a chemical equation, but this is not an ionic equation because we are showing them as compounds, right, as molecules and not as ions. So in order for it to be written as a complete ionic equation, you must separate all the pieces and list them as ions. The reactants hydroiodic acid and lithium sulfide exist as ions in aqueous solution. Therefore, you can write an ionic equation for this reaction. The complete ionic equation that includes all of the substances in the solution. Here it is. 2 hydrogen in an aqueous solution and 2 iodine ions in an aqueous solution and 2 lithium ions in an aqueous solution and sulfide 2 in an aqueous solution react to produce hydrogen sulfide gas and 2 lithium ions in aqueous solution and 2 iodide ions in aqueous solution. Okay. So we're looking, which are our spectators? Which ones do not react? Well, note that there are many spectator ions. When the spectator ions are crossed out, the only substances involved will remain in the only ones that remain in the equation are the ones that are involved. So here's the big old long equation. This is the complete ionic equation. But here is the net ionic equation because these are the things that are actually involved in the reaction, right? We get the hydrogen and the sulfide that react to produce hydrogen sulfide gas. Remember, look at there it is. It's one of the common ones. Hydrogen sulfide, hydrogen cyanide, carbon dioxide. You're going to be watching for the opportunity for those to react. Watch for those. You observed in another gas-producing reaction in the Discovery Lab at the beginning of this chapter. In that reaction, carbon dioxide gas was produced and bubbled out of solution. Another reaction that produces carbon dioxide gas occurs in your kitchen when you mix vinegar and baking soda. Oh, you know this. This is what all elementary students do when they want to make a volcano, right? Vinegar is an aqueous solution of acetic acid and water. Baking soda essentially consists of sodium hydrogen carbonate. Rapid bubbling occurs when vinegar and baking soda are combined. The bubbles are carbon dioxide gas escaping from the solution. You can see this reaction occurring in figure 10.3. Okay. Can't really see it, but you can see the components of it. A reaction similar to the one between vinegar and baking soda occurs when you combine any acidic solution and sodium hydrogen carbonate. Okay, I'm going back to here. Sodium hydrogen carbonate with baking soda. Okay, this is baking soda, although it may not look like that way here in Korea, I don't know. Baking soda is sodium hydrogen carbonate. You can mix it with any acid and get a similar reaction. In all cases, 2 reactions must occur almost simultaneously at the same time, simultaneously in the solution to produce the carbon dioxide gas. One reaction is double replacement and the other is decomposition. For example, when you dissolve sodium hydrogen carbonate, which is baking soda, in hydrochloric acid, a gas-producing double replacement reaction occurs. The hydrogen in the hydrochloric acid and the sodium in the sodium hydrogen carbonate replace each other, okay? And the sodium in the hydrogen, sodium chloride is an ionic compound. Sodium chloride is ionic, you've got to know this, and its ions remain separate in the aqueous solution. However, as the carbonic acid H2CO3 forms, it decomposes immediately into water and carbon dioxide. So, hydrochloric acid, oh dear, I can't read that. Anyway, there it is, sorry. Two reactions can be combined and represented by one chemical equation in a process similar to adding mathematical equations. An equation that combines two reactions is called an overall equation. Okay, overall equation has two reactions happening. It's called an overall equation. To write an overall equation, the reactants in the two reactions are written on the reactant side of the combined equation, and the products of the two reactions are written on the product side. Reactants, products, reactants, products. Then any substances that are on both sides of the equation are crossed out. Okay, so what is on both sides of the equation? Aha, we're listing them together. So see, this right here is here. There are two reactions. This is the same, in the same solution, right? This is all together. So if this is on the reactant side and it's also in the product side, then it can be crossed out as we see here, okay? So the overall equation is HCl, NaHCO3, okay? React to produce, so we don't have this anymore because we've crossed it off with this. So they react to produce the NaCl, where are we? NaCl, there it is, and a water, we see that there, and CO2, carbon dioxide gas, okay? So these match, we've just crossed those off. Notice that this one is a reactant, one is a product, and that's where we're crossing it off. We're not crossing off two reactants, okay? We're going across the line there. In this case, the reactants in the overall equation exist as ions in aqueous solutions. Therefore, complete ionic equation can be written. Here's the complete ionic equation. Note that the sodium and chloride ions are the spectator ions. Okay, so we've taken this now and put it here as a complete ionic equation. Notice that the H2CO3 is not listed in the complete ionic equation. Okay, it's not listed there. So when you and then when you cross them out, only the substances that take part in the reaction remain, and so here's your net. Net means at the end, after you've done everything else to it, your net, what you end up with, okay, is here. Only the things that react, because here we've crossed out any of the spectator ions, the ions that don't react. This is important, an important reaction in your life. This reaction is occurring in the blood vessels of your lungs as you read these words. Carbon dioxide gas produced in your cells is transported in your blood in the form of bicarbonate ion. In the blood vessels of your lungs, the hydrogen HCO3 ions combine with hydrogen ions to produce carbon dioxide, which you exhale, go out of you. This reaction also occurs in sodium bicarbonate products, such as those shown in Figure 10-4, which are used to that are made with baking soda. Okay, we have some more example problems and your section assessment. Okay, hope it helps.